Welcome back to our Selenium Java series. I'm your career assistant, and this is part 2, diving into advanced topics that set junior and senior automation engineers apart. In our previous episode, we covered the fundamentals. Today, we'll explore framework design, complex scenarios, and real-world challenges that you'll face in senior-level interviews. These questions require not just technical knowledge, but also architectural thinking and problem-solving skills. Level up your automation game. Today's session covers 8 advanced areas that are crucial for senior automation roles. We'll start with framework architecture and design patterns, then move through data-driven strategies, parallel execution, and API integration. I'll also show you how to implement custom reporting, integrate with CI/CD pipelines, and handle performance challenges. Each topic includes real-world examples and best practices. This isn't just theory, it's practical knowledge you can apply immediately. Framework architecture questions test your ability to design maintainable, scalable solutions. A well-designed framework has clear layers with specific responsibilities. The driver layer manages WebDriver instances and browser configuration. The page object layer contains all page-specific elements and actions. The test data layer handles external data sources like Excel files or databases. The utility layer provides common functions like screenshot capture and date formatting. The test layer contains your actual test logic, while the reporting layer handles results and logging. This layered approach ensures separation of concerns, making your framework maintainable and testable. Data-driven testing is essential for comprehensive test coverage with minimal code duplication. The key is choosing the right data source for your needs. Excel files are great for non-technical team members to maintain test data. CSV files are simple and version control friendly. JSON files work well for complex nested data structures. Database queries enable dynamic data generation. Properties files are perfect for configuration data. The example shows Testing's data provider annotation with Excel integration. This approach lets you run the same test logic with multiple data sets, dramatically increasing your test coverage while keeping maintenance overhead low. Cross-browser testing ensures your application works consistently across different browsers and platforms. The browser factory pattern provides a clean way to manage different browser drivers. Selenium Grid allows you to run tests on multiple machines and browsers simultaneously. You can set up grid nodes with different browser configurations, then use Remote WebDriver to execute tests on specific combinations. Modern approaches use Docker containers for easy scaling and consistent environments. The key is defining browser capabilities properly and handling browser-specific behaviors gracefully. This approach scales from local development to enterprise-wide parallel execution. Parallel execution dramatically reduces test execution time, but it requires careful design. Testing supports parallel execution at suite, test, class, and method levels. The key challenge is ensuring thread safety. Each thread needs its own WebDriver instance. Use thread local variables to maintain driver instances per thread. Test data must be isolated to prevent conflicts between parallel tests. Consider resource limitations like available browser instances and system memory. The testing.xml configuration shown runs methods in parallel with a thread count of 3. Proper parallel execution can reduce a 2-hour test suite to 30 minutes, making continuous integration much more efficient. Modern applications require both API and UI testing, and senior roles expect you to integrate both effectively. APIs are perfect for test data setup, create users, products, or orders quickly without UI interaction. Use APS for state verification. Check database states or back-end processes that aren't visible in the UIY. Hybrid scenarios test end-to-end workflows, combining API and UI interactions. This approach is much faster than pure UI automation and more realistic than API-only testing. The example shows creating an order via API, verifying it in the UI, then cleaning up via API. This pattern reduces test execution time while maintaining comprehensive coverage. Custom reporting is crucial for communicating test results to stakeholders and debugging failures efficiently. Extent Reports provides rich HTML reports with screenshots, logs, and metrics. The key is integrating reporting throughout your test execution, not just at the end. Capture screenshots on failures, log important test steps, and include system information. Thread-safe reporting is essential for parallel execution. Good reports should tell a story: what was tested, what passed, what failed, and why. This level of reporting transparency builds confidence in your automation suite and makes debugging much faster when issues arise. CI/CD integration transforms your automation from manual execution to continuous validation. Jenkins pipelines automate the entire testing workflow, from code checkout to report publication. The pipeline should handle environment setup, test execution, and result reporting automatically. Key considerations include test environment management, browser driver updates, and failure notification. Use Docker containers for consistent environments across different stages. Implement proper retry mechanisms for flaky tests. The goal is providing fast feedback to development teams while maintaining test reliability. This integration enables true continuous testing, catching issues before they reach production. Performance optimization becomes critical as your test suite grows. Large yield non-subwabdo, Key optimization areas include smart waiting strategies, browser performance tuning, and efficient test execution patterns. Use headless browsers for faster execution when UI validation isn't required. Implement intelligent element caching to reduce DOM queries. Minimize browser restarts between tests when possible. Consider test prioritization. Run smoke tests first, then detailed regression tests. The goal is maintaining comprehensive coverage while keeping execution times reasonable for development workflows. Troubleshooting complex issues separates experienced automation engineers from beginners. Flaky tests are the biggest challenge. They pass sometimes and fail others, making them unreliable. Common causes include timing issues, dynamic content, network latency, and test data conflicts. Effective debugging requires systematic approaches. Enhanced logging to track execution flow. Video recording to see what actually happened. Network traffic analysis for API-related issues, and browser developer tools for element investigation. The key is reproducing issues consistently, then isolating variables until you find the root cause. Document your findings. Patterns and failures often reveal underlying application issues. Modern web applications present complex locator challenges that require advanced strategies. Dynamic content means static locators often fail. Use parameterized XPath expressions to handle variable content. Shadow DOM, common in modern frameworks, requires special handling. You need to access the shadow root first, then locate elements within it. Iframes still appear in legacy applications and require explicit switching. Custom locator strategies can simplify complex selections by creating reusable patterns. The key is understanding the underlying DOM structure and choosing the most maintainable approach. These advanced techniques are essential for handling modern single-page applications and component-based architectures. Memory management becomes critical in long-running automation suites or continuous integration environments. WebDriver instances consume significant memory, and improper cleanup leads to memory leaks. Always call driver quit in finally blocks or at after method annotation. Monitor browser processes. Sometimes they don't terminate properly and accumulate over time. Handle large test data carefully. Loading massive datasets into memory can cause out-of-memory error. Use streaming approaches for large files. Monitor system resources during test execution to identify memory trends. The example shows proper cleanup with fallback process killing. Doubt. Good memory management ensures your automation can run reliably for hours or days without intervention. While Selenium isn't a security testing tool, you can integrate basic security checks into your automation suite. Test authentication mechanisms. Ensure users can't bypass login screens. Verify authorization controls. Users should only access permitted resources. Check input validation, though API testing is better for this. Test session management. Ensure sessions time out properly and users are redirected to login. The example shows testing authentication, bypass and session, timeout. Remember, this supplements but doesn't replace dedicated security testing tools. Focus on user-facing security behaviors that impact the UI experience. Let's summarize the advanced best practices that distinguish professional automation framework. Designed for maintainability from day one, your framework will evolve as applications change. Implement comprehensive logging and reporting. They're essential for debugging and stakeholder communication. Use design patterns appropriately. They solve common problems but don't over-engineer. Plan for parallel execution early. Retrofitting parallelization is much harder. Integrate with CI/CD pipelines as soon as possible. Continuous feedback is crucial. Monitor performance regularly and optimize proactively. Document your framework decisions. Team members need to understand the why behind your choices. Finally, invest in training. A framework is only as good as the team using it. Here's a real-world scenario you might face in interviews. You inherit a test suite with 500 tests taking 8 hours to execute, but management needs results in 2 hours. This tests your problem-solving and prioritization skills. First, analyze where time is spent. Are tests slow individually, or is it just volume? Implement parallel execution to utilize available resources better. Identify and optimize the slowest tests. Sometimes small changes yield big improvements. Consider test prioritization. Run critical smoke tests first, then detailed regression tests. Use faster environments like headless browsers or containers. You might also need to restructure the test pyramid, moving some detailed tests to lower level. The key is balancing speed, reliability, and coverage while managing stakeholder expectations. Technology evolves rapidly, and your automation framework must evolve with it. Selenium 4 introduced new features like relative locators and enhanced grid architecture. Cloud-based testing platforms offer scalability without infrastructure management. AI-assisted tools are emerging for test maintenance and self-healing tests. Mobile automation integration becomes crucial as applications span multiple platforms. API-first testing strategies reduce dependency on UI automation. Containerization simplifies environment management. Accessibility testing integration ensures inclusive applications. Stay current by following Selenium project updates, engaging with testing communities, and experimenting with new tools. The most successful automation engineers are those who adapt continuously while maintaining solid fundamentals. That wraps up our advanced Selenium Java interview questions. The key insight is that senior automation roles require architectural thinking, not just coding skills. Framework design, performance optimization, and integration capabilities separate good automation engineers from great ones. Your action plan should start with assessing your current framework against these practices. Identify your top 3 improvement areas and create a realistic implementation timeline. Don't try to implement everything at once. Sustainable improvement is better than overwhelming changes. Share your knowledge with your team. Great frameworks require team buy-in. Next episode, we'll explore Selenium with Docker and Kubernetes for ultimate scalability. Until then, keep building, keep learning, and keep automating.